Okay, in this video, we're going to talk about using the z-table for normal populations and for sampling distributions, which are based on large enough samples to also be bell curves. Well, specifically, we'll talk about the sampling distribution of X bar. Other sampling distributions will come later. So here's just an overview of what we'll have in this lecture. First, we'll talk about when to use the z-table. I kind of just said that. We'll use it whenever we have a normal population or when we have a bell-shaped sampling distribution that we know is bell-shaped via the central limit theorem. We'll talk about what a z-value is. And to be honest, we've kind of already talked about this. I just didn't call it a z-value. When we did the empirical rule and we went plus or minus 1, 2, or 3 standard deviations from the mean, 68, 95, 99.7, that 1, 2, and 3, those were z-values. They're the number of standard deviations from the mean. If you're in a population, it's exactly that, the number of standard deviations from the mean. If you're in a bell-shaped sampling distribution, it will be the number of standard errors between the sample mean and the mean of the sample means, which of course is the same as the mean of the population. Talk a little bit about z-table mechanics, and basically the z-table, it'll have the 1, 2, and 3 on there, but you'll also have to be, and what the z-table does allows you to have other z-values, like what happens when we're 1.46 standard deviations away from the mean instead of just 1, 2, or 3. So on that section, we'll just talk about the mechanics of that. First of all, just looking up probability. So if you had a z of 1.46, what would be the probability, what would be the chance that we get from the mean to that many standard deviations away from the mean? And then we'll also talk about finding z-values for percentiles. So that's going to be kind of like moving backwards. So we'll start with, we want to have the 90th percentile, and we want to, given that probability, if it's the 90th, well, between the mean and there will be 0.4. Given that probability of 0.4, what's the z-value? How many standard deviations, in that case, above the mean would the 90th percentile be? So that's sort of like the first part, the looking at probabilities in reverse. Then we'll go through more thoroughly computing probabilities when you have a normal population and with different areas and so on. So let's just move beyond what we did for the empirical rule and move to including other numbers of standard deviations from the mean. We'll calculate percentiles in the normal population. So now we'll look at if we want to find the 20th percentile or the 95th percentile or whatever, we'll show how to compute those when we have a normal distribution and a variety of percentiles, whichever one you want to select. And then we will go to, in fact, this will be the last thing we do, is we'll move beyond probabilities for a normal population to computing probabilities for sampling distributions, in this case, the sampling distribution of the sample mean, when n is large enough to ensure that we have a bell-shaped sampling distribution.